Hi, this is Merlin. So I'm gonna talk about the jackbusters. So this is kind of about the garbage collector. So this is kind of sorry. So this is kind of beginning of explanation of garbage collection, and the we have to see how garbage collection is now kind of made in 2023. So as you see, the technology is is like developing every time, and we have to see like the fundamental of it, how it made from till now. Because if you see how it works, the story of the technology, you can like kind of guess how it kind of optimized, if it is like some kind of optimization technology. So GC is kind of those kind of thing. And what I'm trying to explain in this presentation is Jankbusters. So this is kind of beginning of garbage collection. This blog is originated in V8. So this information originated in V8 blog. So and it made this blog, it post on 2015, and that's kind of old. So don't try to like believe this is truth, because I'm pretty sure it's kind of changed, it's kind of developed. So this is not a truth, but just let you know. So what is junk? We're gonna talk about what is junk and why junk is happening. So what is junk? Junk, or in other words, visible stutters that can be noticed when compared to render of frame within 16.66 ms. So example of stutters. So you have to understand what the stutters means. So what stutters means, like this. In this image, this boy, Irish boy, is trying to speak, and maybe he's kind of very introverted person. So there's like kind of stop thing. Can I have what macaroni? Yeah, those kind of thing. So video stutter is kind of thing, similar with thing. So that means that there's kind of a lot of building, and the reason of it is when Chrome fails to render a frame with 16.ms milliseconds. So this is kind of an example of ha- if the junk is happening in Chrome. So this is an example of junk. So your either rendering will be rendering a frame with 60.6 ms 16 milliseconds with constancy, which means that needs to be constant. Your Chrome needs to be render your website like this kind of amount with constancy. But if somehow it's kind of slow, if it is like kind of slow, that's gonna be terrible for your website. So the reason of junk is when too many objects need to be maintained. I talk about how objects are stored in the heap, and we talk about how garbage collector kind of controls the object, and we talk about the object's lifetime, short-lived and long-lived. And if objects need to move, the reference have to move. So if there's a lot of objects, so that means like the the VA have to track all of this, and this can cost the garbage collection. And if it is really long garbage collection, if this time is kind of wrong, sorry, sorry about the pronunciation. If this garbage collection time is long, That means that it blocks the JavaScript code. And the reason why it blocks the JavaScript code, and JavaScript is single-threaded language, so the thread is happening is by one line, and if garbage collection is happening, so JavaScript have to wait till the garbage collection to stop. So if it is have to be really like have to render really fast, and if there's like long time of garbage collection, that could be result on these visible stutters or junk. So you have to understand what is thread. Thread is a smaller task within process. So think about program. Program is a set of instructions waiting to be executed. That means like program, there's so many instructions of it. Example, if you write the code of the program that you want to build, you have to like you put your expectation on the program. If you click the program reads something, and this program execute, and the program's trying to do the some stuff that you really want to do because you already write in your code, and there's a lot of instruction of it, and the process is act of executing the program. So example, if your program using like object, so process would be like handling these objects or handling stack of it, handling and referencing references of object or stack pointers, and those kind of thing is inside of the process. And in this process, the smaller execution or smaller task is the thread. So now we understand why it's happening, why there's junk happening. But this kind of really easily explained. We're gonna go deeper why it is really happening. So there's two major reasons for that. But before that, so GC is gonna be like this, and your JavaScript code or rendering will be like this. And this kind of cute um, gifs. Okay, I'm gonna stop because there's so many lag. It's kind of bothering. So as you'll see, this kind of stuff is happening because if your website is like WebGL game, you have to your JavaScript code have to track your character movement. For example, if your character movement is kind of vector, so if you're going to y index and you jump, if you jump, you have to your browser have to render the character with some kind of y index. For example, y index goes like 0. 0.1, 0. 0.2, and it go up to like 0. 0.6. The starting point is 0. 0.1. And the thing is that you might don't want to happening like just 0. 0.1 to 0. 0.6, because if this happens, it's gonna result in this. Like it's not jumping. It's kind of how to say it, like spawning. So the browser have to render the character on the y index, so it's gonna be act like a jumping. Think of the image and video. If there's a lot of image that can be works as the video, but the thing is that if there's like no process between those images, for example, there's no if there's no middle of it, if there's like 60 image to make a like 1 second of video, you have to have like a lot of image rather than the first image and the last image, or else it won't be looks like a video. It's gonna be like stutters. And JavaScript code need to track, because if it's like 0. 0.3, It's have to go down because jump is like go up and down. And if there's like garbage collection between this, that is that's like big example of this kind of thing. If your garbage collector block this, there's kind of block incident and that cause junk. So GC is related to the user experience UX. So these are the reasons, but I recommend you to just read it and start the video and read it, understand it rather than memorize it. So why junk is happening? So there's like two major reasons, and one is processing of various bookkeeping data structures, and second is bookkeeping associated with the tracking the lifetime of objects shared between Chrome and V8. So bookkeeping. So bookkeeping means like generally refers to the act of maintaining or managing the metadata or the data of data. This kind of abstract, so I'm gonna explain. So here, she is a librarian. If you submit the book that you borrowed, and the librarian is the one who have to put on the on the right shelf. But the thing is that she have to understand, she have to know about the data of metadata of this book. Example, you borrowed um, computer science book because there's like type of book. There's like computer science, art, or physics. So you chose computer science, but in the computer science there's a lot of stuff. So there's like AI, data structures and algorithm, and there's like website, and there's like security. So there's a lot of data, and, and this library have to maintain this kind of stuff. She have to know about this, and she have to put in the right one. Example, I borrowed the data structure and algorithm book. So she have to go to the computer science section, and in the computer science section, she have to go to data structure and algorithm, and she have to put it in the right space that these books already belongs to. So this kind of example of bookkeeping. So the meaning of bookkeep process of various bookkeeping data structure means like, so there's a lot of metadata of data structure. So it needs to be maintained of this metadata, and this a lot of process that cause junk, and also like that. So we're gonna go first about processing of various bookkeeping data structures. So two example of, first we have to understand the two example are the list of array buffers and each array buffer list of views. So this is not kind of memory about GC. That's kind of optimizing the V8 engine, but that is not kind of relate to the memory, the garbage collectors. But still, this kind of technique, the optimization, and the meaning of the array buffer is low memory buffer in JavaScript, represent fixed size of block memory, but it cannot be manipulated, directly manipulated. We can use view to define and interpret it and or access it. And there's like example of it. We use float 32 array, and we can use uint8 array. So some more, if you're trying to learn about what is array buffer and array buffer list of views, we have to understand what is buffer means. So buffer is region in memory that store the data, but 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 temporary data, but these have to move, so it can be stored as a temporary purpose. And I'm gonna give you example of this. So this is array buffer. We define 8. So this like 8 byte. We cannot but directly access on this. So we use the view. So this kind of type of view. how you see this buffer. So we put buffer on here. So if we view if we view on it, example node buffer, and you can see this stuff, right? So there's kind of example of array buffer and all array buffers list of views. And so having this list allows the browser quickly efficiently handle detached array buffer. So detached array buffer means it's like just the same thing as other objects. If this array buffer is not used, okay, it's not used. But rather than like trying to search the reference of array buffer, the browser can see the views associated with the array buffer. So and if it is detached, so you can use detach array buffer operation. But thing is that WebGL based games create a lot of array buffers, even though it's the views are associated with the array buffer. If there's a lot of views, if it's a lot of array buffers, this can be cause the garbage collection, a lot of garbage collection, and if it's long garbage collection, that could be cause of the junk. So example, a WebGL render context, you use a buffer data method, so that could cause some junk. So we put, so this is kind of problem with that, but I talk about this before diving into what is like junk on it. So V8, so V8 engine or Chrome the developers, they also seek the resolution or how to find the answer of it if there's a problem. So there was a problem, and we engine developers they decided to put the checks on every load to store array buffers. If it's like array buffer, they put check on it, out of check on it. So they let compiler to check on it to see the check on it. So rather than go see the views, they see the check or uncheck, so they can just ignore the unused array buffers or detach the array buffers rather than looking at the views. So next is bookkeeping associated tracking the lifetimes of objects shared between Chrome and V8. This kind of lots of work, so I'm gonna try to give you example. So here's the Chrome, and Chrome creates the handle data type, this kind of opaque data type, but that controls or manipulate the V8 heap object. So if it is not longer manipulated, if it is not longer used, the V8 garbage collection it collects the garbage. But the thing is that so so V8 creates an internal data structure called global reference. So the global reference this string, these lines are global reference. So it tracks, right. But if there are a lot of objects and the GC comes, and if GC comes and if GC takes really long, that could be jank, result in the jank. So like WebGL, for the WebGL, so it creates a lot of objects, right? So it could cause the jank, but the resolution or the resolution based on that problem is, so they usually WebGL function is like they use like small arrays as parameters, and underlying data is copied on the stack. So make the global reference no longer track on it. So it's gonna be like it. That means like it. You don't have to find the tracking stuff. And because if the garbage collection is the one who trying to track the reference, but if the tracking way is really long, that could that could cause the garbage collection that could increase the garbage collection time. So it used this kind of stuff, copy on the stack, stack because there's no garbage collection in stack. Operating system handles the the memory via stack, but not the heap. We talked about that before, because is not heap isn't is for the not fixed data, or and so it's storing the object. So object community WebGL often pass along and never actually modified. So it enabling simple static escape analysis. So the just to see what is escape analysis. So escape analysis means that, to make it simple, I'm not gonna go deep with it because this is not about operating system. So if it's like pointer, so variable is located some process, and if the pointers is not gonna be used, or it's not related to the some kind of thread or some kind of scope, so it could scope it could the variable can escape the thread of the execution. So that could be a resolution. I don't know in 2023. So this is like based on 2015. And so I'm pretty sure that is much changed now. But just just looking at the stories could help the understanding of GC. So this is ending of the part one of GC. So we're gonna go about Jankbuster part two on next video.